This is the Banana Data Podcast, a podcast hosted by Data IQ. I'm Trevani.
And I'm Will.
And we'll be taking you through the latest and greatest in data science, without taking ourselves too seriously. This week, we're taking a look at AI's impact on the world outside of tech, with a retrospective on GDPR's first year, the so-called AI job apocalypse, and the environmental impact of our models.
So the first article I wanted to discuss comes from Slate, and this was actually from a couple months back, but a couple months back was significant because that was the one-year anniversary of GDPR. And so this article is called, How is GDPR Doing? So basically taking stock of the state of data privacy in Europe and abroad, and looking at GDPR and kind of the status quo. Are you familiar with GDPR?
I mean, I'm familiar with it as a principle, but the exact sort of requirements, I'm not.
Yeah, I think that you're not alone in that. But so again, I think we've discussed this a little bit here and there on the program previously. GDPR stands for General Data Protection Regulation, and so this was instituted roughly a year ago in 2018 by the European Union. And so the whole point of the General Data Protection Regulation was to protect consumers in Europe from data privacy breaches and from inappropriate uses of personal data. And so the article talks about how it's doing, and it's probably not surprising to you, but it's kind of a mixed bag. Some things that are good are the GDPR mandated a more accelerated time to the reporting of data breaches.
Okay, yeah, that's important.
So if you're a company and somehow your data is breached, in the past, there wasn't really a mandate, or I think the mandate existed, but it was far more lax as to how soon you need to tell regulators, you need to tell the public that, hey, this thing has happened. Sorry, take action to protect yourself. Now it's actually shrunk that timeline down to 3 days. And the statistics in terms of the timeline for breach reporting and also the number of breaches reported has gone up exponentially. So in that case, it's really been a success. But one area where GDPR has failed, according to some critics at least, and according to this article, is in the implementation of fines. So GDPR was, again, supposed to help regulators really hold these companies to account and subject them to high fines if they failed. But really, since the implementation of GDPR, there's only been 60 million euros levied of fines. And 60 million euros, like, if you gave that to me, that would be nice. It's a lot of money. But if you think about all the organizations that are in play here, it's really not that much. And in particular, that accounts or it includes 50 million euros, which was a big settlement that Google faced at the outset of this. So really, when you subtract 50 from the other 60, not much. But I think the thing that we should really focus on is how GDPR affects consumers, because that's kind of the whole reason that it came about. And so I think to the point of what is GDPR, do people understand it? Do people understand what it's doing? I think that's one way in which GDPR is really still failing. Well,
so do these articles at all talk about how consumers feel like they may or may not have benefited from GDPR, right? Because it sounds like this is very business broad strokes oriented in terms of the analysis.
Yeah, I mean, I think that some of the statistics on this are not super great. I mean, one article I was looking at says that things like measures of consumer trust in the digital economy haven't risen. In fact, they've decreased. And one thing more broadly is that individuals, I think, just aren't even aware of necessarily what GDPR is, and more importantly, what rights should come associated with it. So things like understanding, how your data is being used, your ability to demand data portability. So if some organization has access to my data, I can say, hey, I want to be forgotten, or I want to access that data from you and give it to another organization. So just this understanding of the rights that GDPR should give to data consumers, I think is important.
Yeah, and it sounds like, again, this is a sort of high-level overall, how many fines have been brought on, and what are the broad strokes that have happened. But in terms of a actual causal relationship, right, how do we go about determining the real effect? We could sit here and say, hey, businesses are not getting fined as much, and I believe I read something somewhere else that said startups have really suffered under this policy.
Yeah.
Okay, so you've said that, right? You've given me a broad stroke, but how can we go about understanding the impact of this policy in a really specific, causal way?
Yeah, I think this is where we all, me and the podcast listeners, we look to you, Trevani, for your insights in terms of political science here, because really this is something that we've talked about a lot on this program previously, the need for regulation in terms of data privacy, in terms of algorithm development. But what's concerning to me, probably most of all in preparation for this episode, kind of doing my own little mini literature review on this subject, is just the fact that no one knows what the truth is, right? Has this been good? Has it been bad? Is it negatively impacting businesses? What does that even mean to, on net, negatively impact businesses? I just feel like maybe it's too soon to tell, but also maybe we just don't have good enough tools kind of in the poli-sci or policy.
Well, I mean, what we could do is run an experiment where we give some people GDPR and some not. No, I think what's hard for understanding the social and economic impact of certain policies in this way, right, is that from an economics perspective, it's very easy to say, oh, business went down, or companies are fined this much, which in turn reduce their revenues by X amount, blah, blah, blah. Thus, it's bad. But that's predicated on a belief on how you think policy should affect the economy and what the output of economy should be. So that's one whole side of like the economic view. But from a social view, how do we disentangle the effect of GDPR from what's happening in the world? So like you're saying, consumer trust has gone down over the past year, but GDPR is not the only thing that happened, right?
Sure.
Facebook, all this stuff came out, and it's not such a direct one-to-one relationship. So I'm also a little wary of studies that try to say, okay, the impact was XYZ, or it was good, or it was bad. It's a very gray situation. And the fact that on first blush, some companies are suffering under this policy, or GDPR is not finding companies hard enough, is not enough of a reason to say, let's, this thing is good or bad, to put some sort of value on it, right? Yeah. It's a policy. It needs to be part of our AI toolkit.
Yeah, it's super easy to measure the costs. I think that's a fallacy here, saying, look, there's, all these companies had to go out and hire data privacy officers, and that was non-trivial, and conforming to regulations is non-trivial. And I don't doubt that that is a cost of businesses in our economy. But what are the benefits to consumers? I think we need to do a better job of measuring those, understanding those.
And recognizing that those benefits might not be tangible and measurable. And so the cost benefit isn't exactly one-to-one, because the cost is in money to the company, but the benefit to us as consumers, to like the status of AI regulation and protection as we move forward, that's a benefit that really is intangible to me.
Yeah, agreed.
Right. So it's interesting that we're talking about the use of policy to help guide AI in the future. It brings to mind this article I read called "The Answer to the AI Jobs Apocalypse is All About Geography." Right. And so this is written by Frey, and he makes the argument that, well, one, the AI jobs apocalypse is coming, right? Which I think you and I probably both take issue to, and we can discuss. But one, as that sort of job replacement happens and people who are maybe mid-level skilled or quote unquote unskilled, like cashiers and truck drivers and what have you, those folks will lose their jobs. And as a result, they'll be left in sort of a precarious economic situation. So the solution is actually housing policy. So how we do housing policy across cities, across states, not even, and nationally and at the world level. So it's an interesting sort of link he's trying to make here between the rise in technical advances and the associated sort of social problems, and his answer being housing.
Yeah, as you note, a bunch to unpack there. This idea, first of all, the AI jobs apocalypse, I think it's not totally invalid, but to some extent strikes me as somewhat clickbaity, to be honest, just because you could definitely frame our progress that we've made with AI as a potential contributor to a jobs apocalypse. And by this, I think the author means, as you note, quote unquote, unskilled labor being replaced by automated machines. But I'm a big fan of Tim O'Reilly of, the O'Reilly textbook series. One of the kind of key theses that Tim always harps upon is this idea that, we shouldn't have AI to replace humans, but to augment humans. That's also something we've talked a lot about on this podcast. And I think that's kind of this beautiful vision, and whether or not it's real, I don't know, but I'm optimistic and genuinely at this point in time believe that it is. So if you think about truck drivers, I read at some point someone was saying, the truck driver doesn't just navigate the truck on the road, but they also have to load and unload the cargo. They also have to keep that cargo safe. They also have to communicate with the individuals that their transportation and logistics company works with. Like, it's not just one task alone. And I think that's a fallacy that we often get caught up in when we talk about AI replacing these jobs. And so, first of all, kind of to take a shot at this article, I think we should just be thinking about not AI replacing jobs, but how we can use AI to augment the skills of these workers. So if you think about, the restaurant industry, right? I know there are restaurants now that are fully run by robots and AI services, but in reality, wouldn't a better restaurant experience be one in which the things that could be automated are automated, but I still like talking to humans, you still like talking to humans. Like, there's still value that a human can add while also working in tandem with an AI tool. So I want to preface this all with that, but in terms of, AI and geography, I mean, I think that's a fair point. It's something that we're not doing very well with as a country right now.
Yeah, no, and I understand what you're saying, and I agree too that we're not really headed to an apocalypse, right? But I think in his mind, he's thinking about this change or this coming sort of AI revolution, similarly to how we had the Industrial Revolution and the first sort of technical revolution. And people's lives changed, right? What they were going to do day to day changed. Where they were going to do it changed. And at that time, the response to this new technological shock, whatever it might be, whether it's like factories or other kinds of things, was to move, right? So now there's a factory 2 towns down that I can use, that I can go to and earn a living. So I need to move my family. Okay. Migration was actually very useful in helping mitigate the effects of the shocks in those revolutions. But now the author is saying that, well, in fact, with the AI revolution, migration is not so much of an option because people don't have the means anymore to do that. It's a lot more expensive to move to a new city, find an apartment, get a car, whatever it is, and then try and find another job. So the same things that we used in the past to sort of handle new changes in our work, right, aren't going to apply anymore. And so whether or not you agree that there's an AI apocalypse, you can see the effect of, changes in technology, exponential sort of growth in Silicon Valley, Seattle, New York, Boston, that have led to housing issues and housing crises.
Yeah, I mean, I guess that's totally fair. I think you've read Thomas Piketty and Capital in the 21st Century. So this idea that people who own, the means of production, quote unquote, they've experienced higher rates of growth than, the individuals working in the factories, for instance. And so now I guess you're right that like we have these new owners and they're not necessarily owning factories, but they're owning, I guess, data and algorithms, really. Yeah. And so that's definitely valid. I understand that.
Yeah. So, I mean, I guess to sum up, the argument here, of course, is that since migration is not really an option, maybe in these bigger cities, we need to redefine sort of land use regulations, which are preventing more housing from being built. And as a result, driving up the cost of rent, as well as zoning, right? Because what happens is that when folks who are well paid come into a city, they say, I want to live in this fancy area. And coincidentally, those are the same areas that are going to get zoned for quiet zones and schools and better sort of services, and places that are less expensive are going to get zoned for, bars and restaurants and things that are loud and not great to live around.
Yeah.
So the housing policy here in his argument is that you can sort of create a more sustainable city. So even as people's jobs change or their relationship to AI at their job changes, they still have access to the other things that are important, like a good house and eventually good education, so that your future, the future can be educated on how to work with AI better.
All right, so now it's time for everyone's favorite part of the program, In English, Please. So in this section, we explain complex data science topics in English. So Triveni, could you explain cloud computing in English, please?
Well, when we think of cloud computing, you might think of, rain clouds or stormy days, but that's obviously not what we're talking about here. Cloud computing is essentially doing some sort of work or data storage or anything really on a remote machine. So what do I mean by that? Well, a lot of us probably have laptops and desktops of our own, when you're working at your own laptop, you're, on premise. You're using the computer in front of you and you're using its resources. But let's say I'm working on a project that has a ton of data and a lot of heavy processing power is needed for it. Well, instead of going out and buying a brand new computer for $7,000, I instead can rent someone else's computer to run my program on, right? And that someone else is often a cloud service provider. So what does that mean? Well, you think of Amazon or Google. So they say, hey, I'll let you rent my server for 1 cent an hour, and you can run your program on my computer. And because it's remote, I'm going to have to connect to it through a stable internet connection. And in that way, we say you're working in the cloud, right? So if you've ever worked on a Google document with your colleagues or friends, you're doing work in the cloud. You have a shared, a shared document or something in a remote server where you're all accessing it individually through your own connections. And so now what does that server situation mean, right? Is it literally one computer that everybody's pointing to? No. What we have are actually giant factories and warehouses full of servers where people can ping in and get cloud computing power from anywhere in the world. So not only are these centers distributed both widely in terms of the world geography, also internally in each state or in each place, you'll have multiple servers to help route traffic from people to servers that are closest to them. Again, because it is an internet connection, you want to be as close as possible to your servers that you're using for cloud computing. So cloud computing, in a nutshell, is allowing us to do work or data storage or whatever it might be on a remote computer without having to go out and buy all of the actual hardware needed for that processing power.
Very cool. So cloud computing allows me to rent resources that I might need in kind of a scalable fashion, wherever I might be on the world.
Yeah, that's actually absolutely right.
Thanks for explaining that in English. All right, so the last article I want to discuss today was written by Karen Howe in technologyreview.com. It's called Training a Single AI Model Can Emit as Much Carbon as 5 Cars in Their Lifetimes.
Wow.
So the point of the article is relayed right there in the title. It's all about the environmental impact and carbon footprint of AI model training. And as you can see, I think it's probably a shocker to many individuals reading this and even practitioners in the field that AI training can have such a gross impact on our environment. And so then the author kind of tries to suggest ways that we could resolve this or things that we could do to improve. But mainly, to be honest, I feel like the point of this article was just to grab your attention and make you aware of this problem. And so maybe it's up to you and I right now on this podcast to brainstorm some solutions. But definitely shocked me a little bit.
Yeah. Well, no, first of all, how are my AI models doing that, right? Because I'm not doing anything that sophisticated. But even if I was, this is all happening in the cloud, like we just discussed. So why would that even happen?
So basically, computers require energy, and energy comes from power plants, and power plants emit carbon. And there's actually a pretty cool table in this article where the author breaks down for various models that have been trained kind of as benchmarks, in this case, the NLP field, what the energy consumption was, and then using kind of standard techniques in the environmental space, converting that energy consumption into estimates of pounds of CO2 emitted.
And so she's saying that these models are actually requiring, the CO2 emissions of 5 cars, basically.
Yeah. And so in particular, it should be noted the difference between a model trained without neural architecture search and a model with neural architecture search was quite drastic. In short, neural architecture search basically implies that in training a neural network model, you also are using mathematical techniques to determine the appropriate architecture for the model. If that's all Greek, don't worry about it. But if some of our listeners are familiar with neural nets, which they should be from a previous In English Please, maybe that'll make some sense. But in general, the idea here is that the training of these models just takes a lot of time. The computers, or the servers, we should say, the cloud servers are running for a while. And when you do the math, it's actually pretty astounding. The energy that's used is really quite a lot.
But are those models even any better than the ones that might not require as much energy?
Yeah, and this is where it gets complicated, right? I think if you have a novel technique and you want to make a real contribution, at least at the moment, a lot of the computational techniques that we're using, the experts in the field are using, they're not so efficient. So you do probably need to go through this really compute intensive process to make big progress. So if you think about BERT, which is a really cutting edge natural language model, there's 110 million parameters that need to be learned in the training of that model. And that takes a long time, and that takes a lot of energy. And in the result, kind of the combination of that compute resource plus, the good insights from the authors who wrote the paper, that led to kind of a benchmark and a new step forward for the NLP space. So there was good that came of it,
Right.
But at a high environmental cost and
Right.
a high energy cost is what this author is claiming.
So given that we've been talking about AI in the world today, when we think about the fact that carbon emissions are bad for the planet, I can see how there might be a negative sort of, oh, well, we shouldn't be using AI, or we should be trying to use these systems in a way that's better for the planet. But also the sort of physical geography of this all, right? Because we have made the argument that, or as we know, servers are located worldwide. And so the carbon emissions in the US are going to have a different impact than in Europe or in Asia or in, LATAM, right? And the fact that, there are certain countries that do carbon offsets. There are other countries that are taking different stances on emissions is important. And I'm curious to think through how climate policy might actually be affected by AI. We talk a lot about how AI could help us save the climate, right? But also maybe it's hurting us along the same way. So
yeah, no, that's a scary but interesting thought, and it probably is already being done. I'm just ignorant to it, right? But these large cloud computing vendors, they're not stupid, so they're probably running these servers in places where they can get cheap energy. And unfortunately, in this day and age, with the way environmental policy is set up, cheap energy sometimes, often, I would say, is maybe dirty energy. So yeah, that's probably kind of the gross underbelly of AI model training, and yet another thing that we should all be a little bit more cognizant of.
Yeah, but I do think at the same time that realistically, how many of these AI models that emit that much carbon are being run at any given point, right? Like there are researchers everywhere, there are companies doing big jobs or whatever, but like you say, there are also a lot of cloud providers, and they have these systems everywhere. So I wonder at net, what is the real impact versus sort of like of these specific 5 models that they trained? Because I'd like to understand that impact at a larger scale to then be able to draw some sort of conclusion. This article, while super interesting, does also strike me a little bit as like, I don't want to say fear mongering, but like overly cautious.
Yeah.
Given that there are so many other places where the climate is being continually impacted.
Yeah.
Like AI is not our only problem.
Yeah, I would agree with that. But another fear-mongering point that the author makes, which I think is somewhat relevant, is just thinking about the advance of knowledge in this space and how it used to be that just a good mathematical theory could kind of net you progress in the space. But now they argue, you need to have a good idea, but you also need to have the compute resources to back it up. And so as we just discussed, maybe you don't have a big server yourself, but you can run it on, AWS, for instance. But then also in this table here, they say that the training of BERT, they have the energy consumption, the carbon footprint, and then also conveniently in the article, they give the cloud compute costs, roughly.
Right.
And so for BERT, they estimate it was somewhere between $4,000 and $13,000.
Wow.
So again, maybe you can access a server through cloud computing resources, but you also then need to have $10K to drop on this model training. So again, not trivial, something that we need to work on. And I think for kind of the more theoretical math practitioners who are listening, kind of at a high level, in addition to environmental considerations, a really easy way to solve this is just to think about, more efficient algorithms. So our brain, my brain does I think a decent job of understanding language.
Yeah, for the most part.
Day to day, depends. And I'm not using nearly this much energy.
Right.
We're much more efficient machines when you think about it in that way. So there's still a long way for us to go to design machines that are as intelligent as our brains. But then once we get there, they need to not only be as intelligent, but also be as efficient. So in so many ways, I think there's a lot of progress for us to make.
Yeah, and I think not just the algorithms themselves, but also the hardware used in these cloud computing servers everywhere can be probably more efficient and either use less energy or use different kinds of energy like solar or wind or whatever. And that is also a place of improvement. But what I think this article does in a really interesting way is that it does highlight the sort of real impact of AI on other parts of our world that we haven't really thought about as much, right? We talk a lot about ethics and we talk about people's lives and jobs and housing and all that, but also the climate is going to have some sort of impact or is going to be impacted by AI in some way. So being cognizant of that and trying to help become a part of that solution, I think is important, especially given the power of AI to help solve problems. Let's make sure that we're trying to use it to solve this problem and not maybe add to an already, growing crisis.
Totally agreed.
So now it's time for the part of the episode where I give you a banana fact. And in fact, today I want to let you know that Iceland is home to the northernmost banana plantation in the world, right? So we often think of bananas being grown in really hot equatorial places. But in fact, this plantation that is managed by the Icelandic Agricultural University is only 122 miles or just under 200 kilometers from the Arctic Circle. And they actually produce about 5,000 pounds of bananas a year. But unfortunately, those bananas are not for sale. And they're, in fact, eaten by the staff, faculty, and students of the university.
That's all we've got for today in the world of banana data. We'll be back with another podcast in 2 weeks. But in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Josephine.
It's been great, Will. See you next time.